So we are done with pre-requirement. Let's jump into solving equations. So we are done with variables, expression, like terms, coefficient, and evaluating an expression, that is finding the value. So we'll be starting off with defining an equation. Along with that, we'll understand what is an LHS and RHS. We'll define true or false statement. Using this, we'll understand what's the solution. To find the solution, we'll be using practical method and on pen and paper. So here we'll be learning trial and error method and also balancing an equation method. Okay, so let's start off by recalling the difference between an expression and equation. So in an expression, we don't have an equals to sign, while in an equation, we have an equals to sign. So 4x plus 3 is equal to 10 is an equation. So let's define it. Two expression connected by an equal to sign is an equation, or an expression being fixed for a definite output or condition is called an equation. Okay, so this is an expression. So I'm telling I want this to be equal to 10. I'm putting a condition. So that's when we get an equation. Okay. So in an equation we have a very used and very much required term to know, that is LHS and RHS. So 4x plus 3 is equal to 10 has its own LHS and RHS. So LHS stands for left hand side, and this is right hand side. Okay, right? So that's it. This side of the expression is called as LHS and this side of the expression is called RHS. So I made a note over here, that is we can flip expression and make new LHS and RHS. I've seen kids, they find some question like this, if the question turns out to be like this, they get confused how to do this. So my suggestion to you guys is, you can flip it, that is make the RHS to be LHS and LHS to be the RHS. So I'll explain it in one way so that you guys can understand, but you need to understand this before that. Everything of the RHS has to be copied and everything of the LHS has to be copied. You can't miss anything and you can't put anything extra, and you need not change the sign over here, right? Signs are the same. If this was negative 10, it will continue to be negative 10 in this new LHS and RHS equation, right? So the logic is this. See, I have a circle whose area is equal to a quadrilateral. Say I draw a triangle and a pentagon and all that. 1, 2, 3, 4, yeah, pentagon. So the area of circle and the quadrilateral is same. Now, if I ask you guys, I have a quadrilateral. Among these three, which is the figure which has the same area? So we'll tell, for definite, it's the circle. So a circle whose area is equal to the area of a quadrilateral is same as area of the quadrilateral being equal to that of the circle, right? So it's a connection that has been established between them through the equal to sign. Of course, this is not the only connection you can have. You can have a connection like this, right? So you can have a connection with less than, not equal to. There's so many connections that you will be learning in maths and programming languages as well. But anyways, the point is you can flip things around, the obvious reason being this. If something is equal to that, the other thing is by default equal to the something. Now, the one which links to your topic called as solution. So below is a set of things which I have written, which has been related by equal to sign, greater than, lesser than signs. So pause the video and try to to figure out which is a true statement and which is a false statement. It's quite obvious, so please pause the video and try it out. So here I have 4 being equal to 6, clearly a false statement. This is 3 into 4, 12, 2 into 6, 12. They are equal, so it is a true statement. 7 is equal to 71, a false statement. 12 and 12, a false statement. 10 is greater than 35, right? Oh, sorry, my bad. This is a true statement. 10 is greater than 35, a false statement. 16 is lesser than 10, false statement, right? So true statements are 1, wherein the LHS is equal to RHS. So even something like a constant is equal to the same constant, a true statement, right? So you need not end up just with numbers, you can end up with variables as well. So even expressions as well. So this is also a true statement. Okay, so such scenario is your true statement. So where do we use it? We use it in defining the word solution in a solution of an equation. In this particular phrase, we use the word solution for solution of an equation. So how do you define solution? A solution to an equation is a value or values of a variable or variables that makes a true statement when we substitute it into the equation. Okay, so let me explain it with an example rather than just reading it out. So we have the first example, substitute x is equal to 2 in this particular expression. So we have 10 plus 2 being equal to 12. So 12 is equal to 12. So now we got a true statement after putting a value of 2 in this particular equation. So this is known as the value is known as the input. This part is known as the solution. That is your solution of an equation. Okay. So if I had taken something else, x is equal to 1, it would have not been a solution, right? So if I had taken, substitute x is equal to 1, you have 10 plus 1 is equal to 12. 11 is clearly not equal to 12. This is a false statement, and that's why it's not a solution. So you need to understand what is a solution and what is not a solution. Now substitute x is equal to -1 and try to figure it out if the given value is a solution or not. -1 plus 10 is equal to 9. So 9 is equal to 9. Yes, it's a true statement, and thus it's a solution. Let's substitute x is equal to 13 in this particular expression. Let's see what we get. And I'm equating it to 36. This expression is equated to 36. So 26 plus 10, which is equal to 36. Clearly 36 is equal to 36. This is a true statement, and that's why this is a solution of this particular equation, right? Few more problems. I'll just take a second to show you guys that. In the following exercise, determine whether each given value is a solution to the equation. So all you have to do is, we have expressions and we have bunch of values, bunch of numbers that you can substitute it over here in place of x and try to figure out if it's a solution or not. So please pause the video and try it out. So let me start off by substituting x is equal to 10. So 2 into 10 plus 4 is equal to 14. So this is 20 plus 4. This is 24. Being equal to 14 is a false statement, and that's why this is not a solution, right? Next question. Let's substitute x is equal to 4, and we have 2 into 4 plus 4 which is equal to 14. So 8 plus 4 is equal to 12. Being equal to 14 is a false statement. And that's why this is not a solution. Right? Next question. Substitute x is equal to negative 2. So in place of x I am putting negative 2 plus 4 is equal to 14. So this is negative 4 plus 4 is equal to 14. So the 0 is equal to 14. Again a false statement, and thus this is not a solution. Not a solution. Right? So next one we have 5. I don't think I'll be able to do the last one. So you guys figure it out. And it's quite simple, it's not a solution. But yes, try to figure it out by yourself. So 2 into 5 plus 4 is equal to 14. 10 plus 4 which is 14 is equal to 14. It's a true statement, and that's why we have this to be a solution. Right? This is a solution. Okay, the value 5 is a solution for this equation. Okay. Next, try this out. Pause the video. So I'm going to substitute x is equal to 30. So I have x in two different places, please note that. So we have 2 into 30 minus 10 is equal to 30 plus 3 plus 30. So 60 minus 10 is equal to 33. So 50 is equal to 33, which is a false statement, and so not a solution. Right? Now substitute x is equal to 13. So 2 into 30 minus 10 is equal to 3 plus 13. So this is 26 minus 10, and the answer here is 16. Right? How did I do this? So let's just once, I want to clear this again. Brackets is not there, there is no operation, but there is multiplication and division. In that we have multiplication. So that I did first. Then there was, in addition subtraction, there was subtraction, that I did. And on the RHS side there's just addition. So 16, and yes, we have a true statement, and so this is a solution. Okay, that particular input, right, replacing that value of x with 13 is giving me a true statement, so it is a solution. Understood? So the last one, let's substitute x is equal to negative 1. So 2 into negative 1, negative 10 is equal to 3 plus of negative 1. So again, with as per board mass, we need to multiply before we add and subtract. So this we have negative 2, negative 10 is equal to 3, plus of minus is minus 1. So this is negative 12 and 2, and this is a false statement, right? And that's why this is not a solution. Okay, so right, clear set of examples, try it out. So let's start off with substituting 10 in the given question. So as per board mass, no bracket, no operation, we have division, no multiplication, addition and subtraction. Yes, we have subtraction. and this is a false statement, and this is not a solution. Okay, right, quite simple. Let's substitute x is equal to, next question is negative 10. So negative 10 by 2, negative 10 is equal to 15 as per board mass. There's no bracket, no operation, but there is division. Negative divided by positive is negative. 10 divided by 2 is 5. Negative 10, 15. So this is nothing but addition, right? Because both are negative sign, so we'll add them. So clearly this is a false statement, is it not? Because negative 15 is not equal to 15, and this is not a solution. Okay, so next we have substitute x is equal to negative 4. So negative 4 by 2 minus 10 is equal to 15. No brackets, no operation, division is there. Negative 2, negative 10 is equal to 15. Multiplication is not there. Addition is there. Negative 12 is equal to 15. No subtraction, and this is a false statement. And so this is not a solution. So all this value which we did, all the three value is not a solution for the given equation. So it's not that the value which I am giving has to have. I'm just asking you to check if anything is a solution. So we can see that we can put so many different values, and it's not easy to substitute and check if each value can be a solution or not. So there is a better way, and we need to create a better way. If not, finding the solution is not going to be easy, right? So for that, we'll start off with showing why trial and error is a bad idea. We'll do a practical method of finding the solution using a balancing equation, how to balance the equation practically, right? So we'll see it practically how. Well, next video we'll get to know, and post that we will do balancing equation on pen and paper, right? So just let me put just 30 seconds. So let me put this across. Solution of an equation. When we talk about this, see, in real world scenario, the real world is converted to an equation. That itself is a big task. You have big mathematician, scientist working out to put whatever is happening out there in the world in form of an equation. That itself is a big task, and finding the solution is again an important aspect. So this is something, finding the solution is something that is a real world usage. So many people ask me, or many kids ask all the teachers, what is that we are studying and why is it useful? Well, I can't defend all the topics, but there are certainly certain topics that you are studying in maths and physics, right, which is practical, and I will be making it practical for you guys, linking it to real world as and when it comes, and as and when the topic comes, right? So check out the next video and enjoy the practical way of finding the solution of an equation.